6 for the unit test. 265. There will probably be 1 or 2 questions solving equations on your final exam from 6, and we'll talk about 6 more, but problem is I messed up, and I thought we were one more night in there. I thought we had 6 tonight and then review Monday night and then the next 2 nights to take the test, and we've got the test next week, next Monday and Tuesday. So we're going to do study guide tonight, go over that. I'll do some notes on 6 and post it in Google Classroom. I'll look at the final exam. The equations that we did at the beginning of 6 are probably going to cover us, but we will see. All right. So I am looking at 1 through 3 on page 1. One thing I want you to remember and add in there is that order counts. Okay, when they want f of g of 3, you got to make sure you work from the inside out and get g of 3. So g of x is 2x. Can you guys hear me okay? Okay. So g of 3 is 2 times 3, which gives me 6. So then I need f of 6. Whatever I get for g of 3, I'm going to insert into my x, and that's going to give me of 6 plus 2, square root of 8, and I'm pretty sure they probably simplified. Square root of 8 comes down to the square root of 4 times the square root of 2. 2, square root of 2, yes? All right. That would not be the same if you did g of f, right? Because you would have 3 plus 2 square root of 5 times 2. You wouldn't get the same answer. But I'll guarantee you one of those wrong answers is probably going to be from making that mistake. So let's try 3. And this time we want g of f of -2. starting out with f of negative 2. So negative 2 minus 6 divided by negative 2 is going to give me a 4. So now I need g of 4, giving me 4 squared plus 9. Now it's going to be a 25. Yes? Okay. All right. Sometimes they don't give us a number and they just want us to write the composite function as it is. So let's look at 5. I have f of x is x minus 7 divided by 2, and g of x is 2x plus 7. Again, order counts. They want g of f. That means I need to take f of x and insert it for that x. And then simplify whatever can be. So I have 2x minus 7 plus 7. Those 2's are going to cancel. X minus 7 plus 7. So g of f of x is going to equal to x. Should you try 4 for me?
Are you recording this?
Yes. This time, I have to take g and insert it. So I have 7 for x minus 1 plus 11. So f of g of x is going to be 28x minus 7 plus 11 plus 4. All right. What do you think about 1 through 5? Good? There's only one other thing left on 6.1, and that's the domain of a composite function. So I have 2 over x plus 8 for f of x, and g of x is x plus 1. What's going to be my restriction for f of x? Cannot equal, a negative 8. Right? If x were a negative 8, then, and g of x is all real. So my only restriction, since one of them is all real, and I need f of g, then I need to set x plus 1 equal to that restriction, right? And that's going to give me x is equal to a negative 9. Remember, you always start out with your, if I had had a restriction here, that would have been part of my answer. That's my inside function. So if there had been a restriction here, that would have been the first part of my answer. But there wasn't one there, so then I'm going to go ahead and insert my inside, because the f of g is going to be 2 over x plus 1 plus 8, right? That would be the composite function. And then I would have x plus 9 equals 0. And that's going to give you that negative 9. What about for 7? What's going to be my restriction? Or if I have f of x is equal to the square root of x, and 6x plus 24 for g of x. Again, g of x is linear, so my domain is all real. But f of x isn't linear, is it? Under the radical sign, x has to be greater than or equal to 0, right? What would my composite function look like for f of g of x? G of x is going to have to be inserted for x, so I would have the square root of 6x plus 24. So I have to set 6x plus 24 greater than or equal to 0. So I'm going to subtract that 24, and 6x is greater than or equal to negative 24. And divide by that 6. X is greater than or equal to a negative 4. That's going to be my domain. Anything smaller than a negative 4 is not going to be on my graph. How do you know if a function is one-to-one, talking about problem 6 and 7? Every x can only have one y for a function, right? And you're real used to people saying x cannot repeat, right? X can't repeat. Well, we got to take that one step farther for one-to-one. Y cannot repeat. So if I'm looking at problem 8, do I have a one-to-one function? 13 repeats, right? So it's not one-to-one. It is a function, but it's not a one-to-one function. What about 9? all of my y's, 13, -8, and -12, they are all different. So they are a 1 to 1. When I am talking inverse functions, we swap x and y, right? So write me the inverse for problem 10. Don't change any sign. 6, 6 is going to stay 6, 6. 10, 7 becomes 7, 10. 8, 8 is going to stay 8, 8, but 6, 9 is going to become 9, 6. Please remember, don't change any signs. When you're doing an inverse, all the signs stay the same. How can I determine if 5x plus 25 is the inverse of g of x 1/5 x minus 5? Remember, f of g excuse me, has to equal x, and g of f has to equal x. So for f of g, I have to insert 1/5 x minus 5 for that x. So 5 times plus 25. And I would say probably 40–50% of the time, guys, that people get this problem wrong is because this last number back here always gets forgotten. People will plug this in for that x and distribute that 5, and there's the answer. Don't forget about your number back here. So 1/5 x. 5 times 1/5 is x. 5 times -5 is -25. Plus 25 gives me an x. So far, so good. I have to test them both. This time for g of x, I have to put 5x plus 25 in. So I have 1/5 minus 5. And that's going to be 5x plus 25. And distributing that x, I'll get x plus 5 minus 5 equals an x. Don't forget you have to test them both. I meant to do 12 instead of 11. Let's do 12. So f of g. The square root of x plus 3 has to be in for that x, right? So if I'm looking at f of g, this one's a little bit, they're trying to be tricky, that's for sure. I'm going to have x and I don't know about you, but I'm real tempted to go ahead and subtract those 3's. Can I subtract those 3's? No. That's the square root of x plus 3. And 3's under a radical sign, right? So thankfully, that one showed up first, and I can say no right away, right? Because there is nothing else I can do to simplify that. And that definitely is not just an x. All right, how do I write? There's a lot, and I'm trying to get to the farthest I can on here. So if I'm going too fast, say, Ms. Grant, can we go over that some more? Or Ms. White? When I have to write the inverse function, two steps, swap x and y, and solve for y, right? If I'm looking at 14, I have y equals x squared minus 3. I took out the f of x and replaced it with my y because that just is what it is. So I'm going to say x equals y squared minus 3. My first step is just two-step equation. Add that 3 on both sides, right? So x plus 3 is equal to y squared, square root of both sides, and y is equal to the square root of x plus 3. So the inverse function of x is the square root of x plus 3. Okay, I'm going to get into those equations. We've written in the screen. I'm on problem 15. Remember, we're on the whole premise that if I have a to the x is equal to a to the third and my bases are the same, then my exponents have to be the same also, right? This solves it for me because x would have to be 3. So that means I need to change that 1 over 27 into a 3. How can I write 27 as a 3? 3 to the third. But now I need to make it with a base of 3 instead of a base of 1/3. So what can I do? How can I flip that over? If I make that 3 a negative, that's going to be 3 to the negative 3. Remember, negative exponents are just inverse. So that gives me that negative x is equal to negative 3, so x equals 3. Kind of almost the same step. My base is 2. How can I write 1/4 as a 2? Two to the negative 2. Right? So that gives me 7 minus 3x is equal to negative 2. Getting rid of that 7. Negative 3x is equal to negative 9. Dividing by that negative 3x is equal to 3. Now we said right here 1/4 is 2 to the negative 2, right? We all agree on that? So if I plug this 3 in for this x, I'm saying my answer is x is 3. So if I say this x is 3, then I have 2 to the 7 minus 9. And 7 minus 9 is negative 2. Don't forget that you can always plug in, just like every and any equation in the world, you can plug in your answers. And if you're solving an equation that you just have no idea what to do, work backwards from those answers. Do what you got to do. What would 17 and 18, what would one of them, I don't care which one, look like in a logarithm expression, guys? I have 4 to the third is equal to x. What is that in log form? Base, solution, and exponent, right? Log of base 4 to the x is equal to 3. What if I have, looking at 21, base b of 216 is equal to 3. What would that look like as an exponent? Base is still the base. Remember, that's always your exponent, so b to the third is equal to 216. And we're not being asked to solve those, just rewrite it in its form. All right, so I need some exact values for 21 through 25. We're going to write those. We got to remember those rules. Put an X on the end and write it as an exponent. And then we're right back up to problem 15 and 16. Yes? So X is equal to -3. Yes? All right. What about 23? Hopefully you can look at 23 and tell me your answer to that one. 10 and 10 are the same. What's the only exponent you could raise a number to that it'll stay itself? All right, and what's the only number that you can raise? What's the only exponent I could raise a 7 to that would end up as a 1? A 0. So same thing. What's the base on 25? What base are they doing? When I don't write that in there, and you just have ln1, what's down here? And if you have log1, what's down here? Yeah, 10. Don't forget those when you start punching things into your calculator. It's using an E and it's using a 10. All right, so I'm going to do this a little bit. If I write 29 as a single logarithm, I have can I write that as a single logarithm? Since my bases are the same, I can combine those. And what do I do? What property of exponent says I should subtract? Not my quotient, where I'm dividing. So if I have a logarithm expression with a subtraction, I can, same base, so 24 over 6 gives me, so that gives me log base 4 of 4. So what is this all equal to? 1, right? These are the same. Then we have a 1. What about when I'm multiplying? 8 times 7, which gives me a 56. So again, I have another 1, right? All right, 31. We're in exponential form. Now, even though I got the word logs in there, those logs up here, they're my exponent, right? Can I simplify that? How could I write that as a single logarithm? 30 over 5. So that gives me a 6. So I have 10 to the log of 6. Now what's my base right here? That's my 10 again, right? So since it's in an exponential form, let's stick an x on the end and rewrite that in log form. I'm going to go ahead and put those little 10s in there, right? So what's x? This is a log 10, that's a log 10, those are the same, so that's going to leave me with x is equal to a 6. Yeah, I was going to, you know what, we can right now. We're going to use those properties and simplify. So it's in log form. Let's write it as an exponent. When it's in log form, this is my base and this is my exponent, right? So 2 to the 1 is equal to x plus 4. And x plus 4 equals 2. Subtract that 4 and x is equal to a negative 2. What can I simplify here? Write this as a single. Same concept. A to the x is equal to a to the 3. X has to equal 3, right? I have log base 10 here. I have log base 10 here. So those are the same. And that means 4 plus x has to equal 5. Multiply by x minus 4. And 4 plus x is equal to 5x minus 20. And I subtract that x from both sides, and 4 equals to 4x minus 20. Adding that 20. And dividing by that 4. X is equal to 6. And again, I'm saying x is 6. So if I put a 6 in there, then I have of 10 minus of 2. And since they are both the same, then I have of 10 over 2, which is log 5. And that meets my other side, right? Always remember you can plug them in. Equation tests are always nice because you can plug in what you don't know. What are you going to do with 28? How are you going to simplify 28? Addition goes back to multiplication. So I'm going to write 1 times equals 2. Now that's in log form. What would it look like if I were in exponential form? X minus 5 times x minus 11 is equal to 4 to the second power. Now it's a quadratic for us to solve. So we've got x squared minus 5x minus 11x plus 55 equals 16 minus 16x plus 29. Equals 0. What can I multiply to get a positive 39 and add to get a negative 16? So 3 and 13. What is the problem with using that 3? If you look at your solutions, they only say the 13. What's 3 minus 5? If I did this, I would be trying to take the log of a negative number, and that's an error. It's got to be positive. So I've got to throw out that 3. Okay, now that one would be more of a 6-6 problem. So that much in depth. 26 could show up, something like 26 could show up on yours because that shows up earlier. But 27 and 8 would probably belong more to 6-6. So something like that might show up on your final exam, but it won't be on the unit test. Okay. All right. How about your properties? Breaking down 32 through 34 or expressing as a single 35 through 36. What do you want to look at on there? Just absolutely everything. All right. Remember your properties, and they're in your textbook. Subtraction goes to division, back and forth. Addition, back and forth to multiplication. And when I have exponents, can be moved down in front, right? So that's our, I want to break down 4 times the square root of m over n. So the first thing I've got is 4 times. So I'm going to make a break right here with the plus sign. So I'm going to say log 13 of 4 plus log 13 square root of m. And then for this division, I'm going to make missing my minus sign. Log 13 of n. So I broke it into 3 parts from here and here. There is one more thing I could do. How else, instead of the square root of m, you could be writing that as m to the 1/2, right? So that hits our exponent. So this, in the end, of 4 plus log 13 1/2 log 13 of m minus log 13 of n. Let's look at 33. So 1/2 of R plus 1/2 log 8 of S plus 1/2 log 8 of 7. And just as a bit of cautionary, always watch. If those two end up being the same, then it all has to go to 1, right? All right, so let's do that backwards. And look at 35. Yeah, because that's a ratio. Division goes to subtraction. These are the problems we worked on Monday night. And that box up top has your properties. And that's just cut and pasted out of your textbook. You have all that in there too. So as a single, I'm going to be moving those exponents back up. And then that addition is going to go to multiplication between 2 and 7 times 7 to the 5th. And I don't know if they did. I'm assuming they did because that would be an ungodly number. Just leaving it. I mean, whew. All right, remember your change of base. When you hit the 10 and the log on your calculator, it's going to say a 1, right? Because your calculator is using that base 10. You cannot put in you have to make the ratio. You're going to punch in 2.4 log divided by 7.8 log. And let's see, what does that say in your last page? This should be 37. So let's check and make sure that we can get that on our calculator. Sometimes we might have to use some parentheses. to keep our orders of operation going? So we still have a few minutes. Is there anything on here that I jumped over that you would like to go back and discuss some more? Okay, I'm good, you're good.
34.
34, I sure can. But so I can break, if I have, I don't know, log base A of 2 times 3, I can break that to the plus sign, right? But this could be broken into plus, right, because of my addition property. But I do not have a property for 2 plus 3. Okay? There's nothing you can do with that. That's a done deal. So when I have 34, I have log 2 of x minus. I do have 2 things I can hit. 2 of x minus 3. And you're going to be done with that. Okay? And then minus of x to the 4th. And then that 4 is going to come down in front. So log 2 of x minus 3 minus 4, 2 of x. Does that make sense? You've got 2 times 3, but you do not have 2 plus 3 or minus. Anywhere else?